Which planet in the solar system will allow me to age more slowly than Earth does? How old would you be if you lived on a different planet in the solar system? There are two ways to respond to this question. The first is humorous and lighthearted but rigorous quantitatively, while the second will also be rigorous from a physics perspective. I believe that the only way to combine the two was to present everything as an apologue that could make the point without being tedious. You will be judged. In the far distant future, when humanity had succeeded in terraforming and colonizing the entire solar system, a movement of people who, in imitation of the group of flat earthers that had spontaneously formed centuries earlier, began to declare themselves tired of the complexity of science, gave themselves to the craziest demonstrations of how to live decently without problems. Believing that this would be sufficient to reason with their this would not have been a bad notion at all, except that those who supported this anti-scientific movement meant by reasoning with one's own head the rejection and derision of any logical explanation of how the universe functions. It was either difficult or simple to understand. Of course, life continued as usual. However, as is frequently the case today, even in that far-off future, the media portrayed events in such a way that soon the exploits and rants of the simple people, as they liked to refer to themselves, filled the news and information networks throughout the solar system to capacity, leading the majority of people to believe that a significant social transformation was underway. This led to the emergence of true gurus who could draw ever larger groups of simples and increasing monetary amounts. Just to mention a handful, pi was proven to equal 3, without all those unnecessary decimal spaces, and creation made a comeback in popularity. Someone then got the idea to assert that time must function differently on each planet in the solar system than it does on Earth. The lengths of the revolutions around the sun weren't remarkably different. They also said that if this information had not yet reached the public, it was because those people did not want the migratory flow to other planets to be imbalanced in favor of those who could ensure very slow aging. Even many simples thought this was pure nonsense, but no one dared to say anything because it was supported by one of the most powerful gurus. The simples based their beliefs on the fact that even the astronomy books occasionally stated this, but were unable to comprehend that it was a type of humor that hinted at the varying ages we would have on the many planets in the solar system. They even created a Chronos project to evaluate how much of what they said was accurate or incorrect in order to support their claims. For the occasion, a conference was also organized, and they discussed their plan of action there. We have considered 8 planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, said one of the gurus. We will send one of our affiliates to reside for 10 years in each of these. Or, to put it another way, a replica of one of our affiliates that was selected from those already in existence. Greetings, friends. A day is what? A year is what? The Earth, as we currently know it, is constantly moving. It actually makes multiple motions, but 2 in particular would be interesting to your odd notions about the passage of time. The Earth first revolves around its own axis. Second, the Sun and Earth are revolving. The day is defined as the duration of Earth's axis rotation. This time period is further divided into 24 hours, each of which has 60 minutes, and each of which has 60 seconds. The speed of the planet's rotation is determined by how much rotation there was in the raw material that made each one. There are no rules dictating it. Venus takes up to 243 Earth days to round around its axis, but Jupiter rotates quite quickly, every 10 hours. On the other hand, the year is defined by the Earth's movement around the Sun, which is slightly more than 365 days. Since elementary school, we have been taught that planets orbit the Sun at varying speeds, but that while their periods of rotation are random and unpredictable, their durations of revolution are closely related to their distances from the Sun mathematically. In reality, as Johannes Kepler discovered, the time it takes a planet to orbit the Sun, raised to the square, is inversely related to the average distance from the Sun, raised to the cube. Here is the equation. It is a magical formula because of how quickly we can calculate a planet's distance from the Sun using simply its period of revolution, or vice versa. Let's use the Earth as an example, which is 1 AU away from the Sun or 149.6 million kilometers away. Jupiter is 5 Australian dollars and 20 cents from the Sun, hence its year, or period of revolution, will be 5.23/2, or almost 11.8 years. It's amazing, isn't it? However, from where does this cosmic architecture originate? The idea that the motion of bodies on Earth, the motion of the Moon around the Earth, and the motion of the planets around the Sun share a common cause, a universal attractive force operating on all bodies, was first put forth by Isaac Newton. The force that is released between two bodies is specifically inversely proportional to the square of their distance and directly proportional to the product of their masses. This implies that the force drawing the bodies together is stronger the larger and closer they are. The name of this force was gravity. From this straightforward notion, Newton created a very potent theory known as the theory of universal gravitation, which allows the motion of any body susceptible to gravity to be investigated and accurately predicted. One of the pinnacles of human creativity, the theory of universal gravitation delivers outcomes with an accuracy that beyond all expectations. Newton's theory is still critically important for understanding celestial body motions today. All of this, however, serves to support the figures that will soon appear on the screen and provide us with planet-by-planet information regarding the parameters that you simples have used to support your theory. Hey folks, before we go on, just a quick. Please subscribe to the channel. By pressing the bell, you may assist us in producing goods of ever higher quality. Mercury will come first. 0.387 Australian dollars separates it from the Sun. Its revolution lasts for 88 days, or 0.24 Earth years. MER, who recently turned 30 and is, of course, the same age as all the other clones, will travel to Mercury. The real names won't be revealed. Mercury has experienced considerable polar colonization during the last few centuries. If the simpleton's hypothesis is correct, the unfortunate MER should have aged 10/0.24 years, almost 42 years, by the time it returned. They are therefore roughly 72 years old. He wouldn't likely be pleased about that, in my opinion. For VEN, which you are going to deliver to one of Venus' atmospheric colonies, a few nicer, or less awful, things would go. Let's check it out. Venus, 0.723 Australian dollars away from the Sun, 225-day revolution cycle, or 0.615 Earth years. According to your logic, VEN should have aged 10/0.615 years, or roughly 16 years, since its return. Consequently, I am approximately 46 years old. It goes without saying that in 10 years, the clone EAR who remained on Earth will be 40 years old. Mar will be taken to the Martian colony of New Rome, and luckily for him, he should be one of the clones that you simples believe will be doomed to a delayed aging process. Mars circles the Sun every 1.88 years and is 1.524 Australian dollars from the Sun. It should have aged 10 to 1.88 years, or a little over 5 years, by the time Mar returns, having a 35-year-old age as a result. The situation for JUP, which will spend the next 10 Earth years on the surface of the Dyson sphere being constructed around the gas giant, will be even better. JUP orbits the Sun in 11.86 years. Since it is 5 Australian dollars and 20 cents from the Sun, JUP should be October 11th, 86 years old, or just 0.84 years old, when it returns. You are therefore under 31 years old. However, I want to remind you that this will only happen if your absurd theory is proven to be true. But let's continue. The enormous orbital platform known as Hexagon City, which is situated just above Saturn's North Pole at the top of its clouds, is about to be reached by SAT. Saturn circles the Sun every 29.5 years and is $9.54 from the Sun. SAT should have aged 10/29.5 years, or 0.34 years, or slightly over 3 months, by the time it returns, and have therefore maintained a 30-year-old age. The second largest orbital platform, Herschel, which is similarly situated over Uranus' North Pole, is where URA is ready to embark for. Uranus circles the Sun every 84 years and is $19.20 from the Sun. URA should be 10/84 years old, or 0.112 years, or just less than 1 month old, when it returns. It should also reappear at the age of 30. NEP is preparing to launch toward La Ville de Leverrier, a still under construction orbital outpost above Neptune's North Pole. Neptune circles the Sun in 164 years and is $30 from the Sun. Therefore, by the time NEP arrives back on Earth, it ought to have aged 10/184 years, or 0.05 years, or barely 20 days. And as a result, it should appear to be 30 years old, just like it did when it departed. Ladies and gentlemen, that is all. It goes without saying that none of this, in my humble view, will occur. Your clones will leave Earth aged exactly 10 years older than when they arrived. Actually, no. I erred when I said exactly. Naturally, because they are twins, they will all appear to have aged equally, but there will actually be a very slight difference. Ironically, that complicated science you loathe was entirely able to foresee the difference. What am I referring to? In regards to the actual time dilation, general relativity is the only theory that can account for it. Fundamentally, according to Einsteinian relativity, the pace at which time moves relies on both the observer's speed and the strength of the gravitational field they are in. A clock that is positioned outside of any gravitational pull will move more quickly than one that is, for instance, on a planet. In fact, the gravitational field produced by heavy objects like planets causes localized time dilation. The mass of the planet determines how much faster. So in essence, you are correct, aging occurs at a varied rate depending on the planet you live on. However, not in the quantities you imagine. URA will return from Uranus older than EAR, which stayed on Earth, by 3.9 seconds. NET will return from Neptune 3.8 seconds later than EAR, which stayed on Earth. SAT will return from Saturn older than EAR, which stayed on Earth, by 2.1 seconds. MAR will return from Mars 1.8 seconds later than EAR, which stayed on Earth. VEN will return from Venus 1.7 seconds earlier than EAR, which stayed on Earth. JUP will return from Jupiter younger than EAR, which stayed on Earth, by 2.4 seconds. MER will return from Mercury younger than EAR, which stayed on Earth, by 7.1 seconds. You must have been taken aback. The planet where time passes the least quickly is Mercury. This is due to its fast orbital motion and the fact that, while having a little mass, it benefits more than other planets from being close to the Sun's extremely strong gravitational field. What if we also wanted to take the Sun into account? So, if a hypothetical clone named Sun could stay there for 10 years, it would arrive back on Earth 663 seconds, or more than 11 minutes, younger. When you look at the chronograph display hidden beneath the skin of your clones that have been sent back to Earth in 10 years, there it is, the solution. My dear friends, science is a simple thing, much simpler than your very wacky theories, which are not simple, just simplistic. In 10 years, I'll run into you again here. Maybe.